Okay. Okay. Good evening in China and good morning in Argentina. Thank you for joining us today. Welcome to our third joint webinar organized by the Engineering Academies of China and Argentina on food research and technology. We are pleased to share this activity with you. The topic of this third joint webinar is food safety and quality control. It's a great pleasure for me to invite Engineer Oscar Viñar, President of the National Academy of Engineering in Argentina, to give us the opening remarks. Please, Engineer Viñar.
Good morning and good evening. As a consequence of the collaboration agreement signed by the Chinese Academy of Engineering and the Argentine Academy of Engineering, and with the participation of the School of Food Science and Technology of Jiangnan University and the Center for Research and Development in Food Science and Technology, CIRCA, of the University of La Plata, I am opening today the third webinar on food safety and quality control. I want to thank all the speakers for their participation in this important event. Congratulations. Thank you very much. I will now introduce the international representative of the Jiangnan University, Professor Jian Ni.
Hi, everyone. Distinguished President Oscar Vinard, Dr. Naomi Zarisky, and all the experts, good morning and good evening to everyone. First of all, on behalf of the International Office of Jiangnan University, I would like to extend my sincere greetings to all of the Chinese and Argentine experts and scholars to attend this online webinar and express my heartfelt thanks to all those who have long supported the exchange and the cooperation in food science and technology. Thanks to the joint effort of both sides, the Chinese Academy of Engineering and the National Academy of Engineering of Argentina have successfully held 2 sessions of the joint online webinar on food science and technology. On September 29, 2025, the first session focused on food nutrition, probiotics, prebiotics, and symbiotics, with in-depth discussion on cutting-edge research and industrial applications. On December 10, 2025, the second session focused on green food chains, sustainable packing, and resource utilization of food industrial waste, exploring the path of green transformation for the food industry. These 2 sessions have achieved fruitful results and in-depth exchanges, laying a solid foundation for China-Argentina cooperation. Today, we kick off the third joint webinar as scheduled, focusing on food safety, quality control, and an important issue of global concern. Food safety is vital to people's well-being, industrial development, and public security, and is one of the core directions of technology innovation and international cooperation. We look forward to sharing the latest achievements and the practical experience in key fields, including intelligent detecting, food preservation and quality control, pollutant prevention and control, as well as food authenticity identification. inspiring ideas and building consensus, aiming to contribute China-Argentina wisdom and solution to safeguarding global food quality and safety. We believe that this webinar will further deepen the practical cooperation between China and Argentina in field of food safety and promote mutual learning of technology, exchange of talents, and the sharing of achievements. Relying on our disciplinary and platform advantages, Jiangnan University is willing to continue to work with partners from Argentina and the world to steadily advance international exchange in food science and technology and support the high-quality development of the food industry of both countries. Finally, I wish the third session of the joint online webinar on food science and technology a complete success. Thank you.
Okay. Margarita, follow please with my presentation.
Welcome to our third joint webinar on food research and technology, food safety and quality control, organized by the Chinese Academy of Engineering and the National Academy of Engineering in Argentina. My name is Dr. Noemi Zaritsky. I am titular member of the Academy of Engineering in Argentina, and together with the president of the Argentine Academy, Engineer Oscar Viñar, we are leading this joint project in Argentina. It's my great pleasure to describe the program we will have today in the webinar and to introduce the speakers from Argentina who will give their lectures. The program of today's webinar is very interesting. The first presentation will be given by Professor Xie Junfei, and the title is The Application of Artificial Intelligence in Food Safety and Quality Control. Professor Xie Junfei is from the Chinese Academy of Engineering. The second one will be given by Dr. María Constanza Cova, the title Meat and Meat Product Irradiation, Application for Enhanced Safety and Shelf Life, from Argentina. The next one, the crown jewel, 5-hydroxymethylfurfural by Dr. Wang Xiaonuan. The next one, Meat Quality Program of the Argentine Angus Association, Argentine Angus Beef Attribute by Ignacio Harris. The next one, Microbial Pollution and Control from the Perspective of Climate Change, Strategies for Biological Loss Reduction and Value Enhancement of Grain by the Associate Professor Sheng Lina. The next one, Mycotoxins in Argentina, Current Status and Control Strategies by Dr. Sofia Schulze. And the last one, Application of Multiplex Detection Technology in the Field of Food Authenticity Identification by Professor Zhang Xiujin. Now I will introduce the speakers from Argentina. The first one is Dr. María Constanza Cova. She is a food scientist and holds a master's degree in industrial quality. She is head of the Food Irradiation Division at the National Atomic Energy Commission in Argentina, and she works on the application of ionizing radiation technologies to food. Her work focuses on the development and evaluation of irradiation processes for food preservation, including microbial risk reduction, quality and stability, and shelf life extension across a range of food matrices. She has participated in international research projects coordinated by the International Atomic Energy Agency and is author and co-author of peer-reviewed publications in international scientific journals. Her activities also include collaboration in the development of standards and technical support in regulatory aspects related to food irradiation. In addition to her research work, she serves as adjunct professor in food engineering at the National University of San Martin and in the bachelor's degree in food technology at the National University of Hurlingham. She currently represents the National Atomic Energy Commission as a member of the board of the Food Safety Network of CONICET. Ignacio Harris is a meat science technician with 50 years of experience in the Argentine meat packing and livestock industry. He serves as meat manager and technical director of the Argentine Angus Association, leading the development of the Argentine Angus beef quality attribute. He is also managing partner of LIAF Control, a company dedicated to certification, inspection, and food quality assurance. Harris acted as a technical advisor in the update of the Argentina's official beef grading system in 2018 and was part of the team that developed Paraguay's official beef carcass classification and grading standards. He has worked as a classifier grader and judge of steers and block tests at the former National Meat Product Argentina and participates in technical committees within the IPCBA, INTI, and the Argentine Sustainable Meat Roundtable. Dr. Sofía Noemí Schulze is PhD in Biological Sciences from the National University of Río Cuarto, Córdoba, Argentina, Emeritus Professor at the National University of Río Cuarto, member of the research career of the National Scientific and Technical Research Council in Argentina, CONICET, in the highest category, Senior Researcher. She was leader of an interdisciplinary research group that actively carried out research on pathogen and toxigenic fungi and mycotoxins on cereal grains, wheat and maize on daily seeds, peanuts and sunflower and grapes. The main activities are related to reduce the impact of Fusarium and Aspergillus contamination and mycotoxin through an integrated management. Dr. Schulze was director of the Research Institute on Mycology and Mycotoxicology at the University of Río Cuarto. The research group has done an important contribution to the knowledge of fungal population of Fusarium, Aspergillus, and Alternaria, and an occurrence of mycotoxins in cereals, oilseed, and grapes from Argentina. The group is also involved in teaching activities in the area of mycotoxicology for graduate students from Argentina and other Latin American countries. Also, extension activities are carried out devoted to farmers, industry, private, and official control laboratories. Dr. Schulze has experience in management of national and international research projects and has supervised 14 PhD theses. She was visiting researcher at Manchester University, Department of Chemistry in England, visiting researcher at Pennsylvania State University, State College and also at Kansas State University in the United States. She was Vice Dean of the Faculty of Exact Physicochemistry and Natural Sciences at the National University of Río Cuarto and head of the Department of Microbiology and Immunology of this faculty. Dr. Schulze has more than 150 publications in peer-reviewed journals such as Applied and Environmental Microbiology, European Plant Pathology, World Mycotoxin Journal, Biological Control, and 16 book chapters. She is author of more than 300 scientific presentations at national and international congresses, member of the editorial board of different journals, Mycotoxin Research, World Mycotoxin Journal, Argentinian Journal of Microbiology, member of the International Society of Mycotoxicology, and at present Vice President representing Latin America, member of the Argentine Association of Microbiology, and Vice President of the Latin American Society of Mycotoxicology.
Okay, next I will give a brief introduction of our presentation, the people. So the first one is mine. I was from Jiangnan University School of Science and Technology. So this is my brief introduction. And next one, the second presentation is from Wang Xiaonuan, assistant engineer, Zhejiang Sugar Energy Technology Company. And the second one is Shengli Na, associate professor, also from our school, School of Science and Technology, Jiangnan University. And the last one is from Dr. Zhang Xiuqin, Technical Director, Center Testing International Group. And so this is the brief introduction of us. So that's all. Thank you.
We will begin with the first presentation from China. The next speaker is Yunfei Jie.
Yeah, okay. Please wait. Thank you.
Distinguished guests and colleagues, good morning and evening. I'm Xie Yunfei from the School of Science and Technology, Jiangnan University. It's my great honor to be invited to this webinar. And today, I will share our team's research achievements, the application of AI in food safety and quality control. Today's presentation will be structured into the following 5 contents. I believe all of you have a personal experience that AI, which is now everywhere, from wearable smart devices we wear daily that monitor real-time sports and health data, to the globally widely used ChatGPT. AI has deeply penetrated every aspect of our production and daily life, and has become an important part of modern society. More importantly, in scientific research, AI has demonstrated in transformative in inspiring capabilities, as seen in the top global journals such as Nature and Science. AI has been deeply engaged into almost all disciplines, including biological science, new material, clinical medicine, organic chemical synthesis, and so on. The development of AI has also promoted interdisciplinary integration, bringing new research methods and application areas to traditional disciplines. What can AI do in food sector? AI will empower the entire food production and processing supply chain, including production, processing, consumption, and future. I will give you some research examples from our group. The second part is application of AI technology in food safety detection. First of all, based on deep learning technology, we completed intelligent processing, automatic feature extracting, classification, and recognizing of Raman spectral data. The core achievement is the construction of a Raman spectral database containing over 300 standard samples of cross-border hazards factors. This database has a very comprehensive coverage, including pesticide, voluntary drugs, food activities, illegal added drugs, and environmental pollutants, basically covering the core categories of hazard factors in cross-border circulating of food. At the same time, we have developed a matching spectral database software system. The system can realize one-click rapid identification and quantitative analysis of a hazard substance, laying a solid underlying foundation for the on-site rapid detection of a trace hazardous substance in food. Another work, we designed and synthesized an integrated detection material with dual functionals of target enrichment and signal amplification. The biomimetic turning patent silver needle, addressing three major industry pain points prevalently in current food hazard substantial detection: low inspection and enrichment efficiency, unstable performance of sensing materials, and poor detectional signal enhancement effect. Through the complete achieved cultures of the detection system, we are equipped with a portable Raman spectrometer and a 3D printed bracket, realizing the integrated operation of sample enrichment and detection. Through multi-synthesized effects and AI assistant spectral recognition technology, we established an ultra-sensitive needle insertion rapid detection method for typical hazardous substances in food. This work was successfully published in Advanced Material, the top journal in material field, and was selected the cover article based on the innovative integration of chemical materials, machine vision, spectroscopy technology, machine learning, and other technologies. We have also designed and synthesized a series of high-throughput detection substrates, including enrichment detection, integrated biomimetic substrate, and graphene nanocomposites. For microplastic pollution in food, we have established a spectral identification method for microplastics of different materials, which can accurately identify common microplastic categories such as PE, PP, PVC, and PET. For complex metrics such as milk, eggs, chicken, beef, mutton, and animal often, we have established an accurate detection method for voluntary drug residues. Shown on the page are the multi-channel chromatograms of the target substance in different metrics, with detection stability and recovery rates fully meet the national standard requirements. Based on these core materials and AI technology, we have developed more than 30 sets of safety detection-related solutions, as well as supporting detection regions, core components, and complete sets of equipment. In addition to the front end of detection technology and equipment development, we have also deeply integrated AI, big data, Internet of Things technology with automatic equipment. This is an example in milk company. The laboratory automatic detection system we built covers the whole processing, including physical and chemical index detection, automatic reagent preparation, microbial culture, and rapid detection and sample processing. So you can use this system. It can cut the time and also cut the people. This is the example of that. So using big data, AI, IoT, and automatic equipment, it quickly detected food harmful substance, optimized formulas, enable food substrate traceability, reduce labor, boosts efficiency, and ensuring testing accuracy and product quality. This example is that the milk company used the AI system such as SAP, BIBS, MES, BI systems, enable real-time monitoring of core material and the product indicators, big data analysis for indicator, supplier, processing, market, lab, and operation management with one quick click, full traceability to ensure quality. The third type, the third part is application of AI technology in food quality control. As you've seen from this presentation, which includes 5 core molecules. The first one is the intelligent environmental monitoring system, and the second is the intelligent data system, which can collect core data such as sensory quality, biochemical indicators, and freshness of food in real time. The third one is the data integration and analysis system, which is the core of our AI large model. The fourth is the intelligent decision control and support system. The fifth is the feedback automation system, forming a full closed loop management of monitoring, accuracy, analysis, decision making, optimism, and this can solve the industry pain points of large and extensiveness in traditional preservation models. In addition to the intelligent upgrading of the preservation system, we have also carried out AI-assisted research on new preservation in habitats, addressing the industry challenge in food preservation, using virtual screening technology based on performance models, combined with cutting-edge AI technology such as deep learning and generate adversarial networks. We have complete low-cost and high-efficiency screening of more than 2 million small molecule natural inhibitors with an experimental refactoring success rate of over 70%. Relevant achievements have been fully applied to various natural food preservation. Next are the breakthrough achievements of AI in the field of intelligent food freshness recognition. This one, we can deeply integrate the physical process of odor recognition with conventional network and developed an integrated color sensory aerial system for meat freshness, especially for beef, chicken, fish, and shrimp. And this work was successfully published in advanced material as a cover article. In the future, we want to develop this technology in the consumption, maybe for the package, to let the consumer to know how about this freshness of the meat. And next, we also developed a non-destructive food quality detection solution based on 太赫兹 spectroscopy, combined with spectral data processing, feature extraction, and model constructed by AI. We can realize real-time, non-destructive online monitoring of moisture content and quality of fruits and vegetables. At the same time, we have also achieved online monitoring and automatic sorting of egg freshness based on technology such as near AR and hyperspectros combined with AI. We have integrate various non-destructive testing technologies such as Raman spectroscopy, X-ray, and near IR, combined with AI deep learning, and implement multi-industry applications such as repeated freeze-thaw testing of meat, intelligent grading of beef and mutton, automatic sorting of fruits and vegetables, identification of hidden defects inside products, such as detection of foreign objects in production process. And the fourth one, we'd like to talk about the large model of food AI. Last July, Jiangnan University, in collaboration with iFlyTech and Huawei, officially realized the world's first large-scale model for the food vertical field, FoodSeek. It has now been intelligent to version 3.0, officially in a real era of food science AI. We have intelligent a full range of different food field, including scientific research, literary, professional database, knowledge graphs, professional books, patents, standards, and so on, and completed the secondary pre-training of the model. And we hope that use that in teaching, research, science, population, and social service. So we also combined with government and the company to use this AI model to a lot of areas. In the last part, summary and outlook, we believe that the core influence factors of the whole food processing are always the two core dimensions of safety and quality. Our goal is to start from the basic principle and to the real application. So we want to found the molecular structure and physical properties, interactions, molecule interaction mechanisms, and also the reduction and the generation mechanisms. And after that, use the physical, chemical, sensor technology and online portable monitoring equipment and also the IoT technology, and to at last to develop of online detection equipment for food processing. So it needs a lot of cross research and also the university and the company. So thank you very much for your attention. So if you are interested in this area, please contact me with email. Thank you.
Good morning. I want to thank the National Academy of Engineering and Dr. Saritsky for the invitation to be here. I'll be talking about meat and meat product irradiation application for enhanced safety and shelf life. Regarding the irradiation technology in Argentina, we have two gamma irradiation facilities. One of them is at the Seiza Atomic Center, is the facility from the National Atomic Energy Commission, and the other is a private company, and both are located in Buenos Aires province. Food irradiation it's a physical method of food preservation. It consists of exposing the food to a source of ionizing radiation for enough time to reach a specific dose. The absorbed dose is the amount of ionizing energy absorbed per unit mass of the irradiated material. 1 ray is equal to 1 joule of absorbed energy per kilogram of irradiated product. Let's look at the properties of ionizing radiation treatment. First, it has high penetration depth and there is no temperature increase. So it can be used for food and packaging that are sensitive to heat. It doesn't change the state of the food, and normal packaging allows the radiation to pass through. It can be used on packaged products avoiding recontamination, and it can be applied in bulk or in packaged products. About the purpose of food irradiation, the main goal is ensuring hygienic quality. We do this by removing or reducing biological hazards to safe levels, and controlling pathogenic microorganisms, in special bacteria, molds and yeasts, and parasites. Another key purpose is extending shelf life and reducing losses. We achieve this by delaying deterioration in vegetables, such as protein and ripening, reducing the load of spoilage microorganisms, and eliminating insects that cause damage during storage. The use of irradiation on meat and meat products. The primary goal of meat irradiation, pressed, processed, chilled, or frozen, is the elimination of pathogenic bacteria and parasites to lower the incidence of foodborne disease. Campylobacter jejuni, E. coli, Listeria monocytogenes, Salmonella, and parasites like Trichinella spiralis, Toxoplasma. At the same time, the commercial life of non-frozen meat is extended by lowering the spoilage microflora count. Now I will introduce our study on salamine, a traditional Argentinian dry fermented sausage. In this study, we evaluated the use of gamma irradiation to control Listeria monocytogenes in vacuum-packed samples under refrigeration. And here are the main findings. Gamma irradiation at doses of 4 to 8 kilograms was evaluated to control Listeria monocytogenes in vacuum-packed dry fermented sausage. We call this product salamine picado fino under refrigeration. A dose of 4 kilograms was identified as optimal, achieving a 5-log reduction of the pathogen and ensuring its absence at the end of shelf life. Sensory quality was maintained up to 90 days with a shelf life extension of 30 days compared to the commercial product. Higher doses led to sensory deterioration. Next, in this study published in Meat Science regarding ground beef, the goal was to identify the optimal dose of gamma irradiation to control Shiga toxin producing E. coli while maintaining consumer acceptance. Here is the summary of the study. In this case, gamma irradiation was evaluated to control Shiga toxin producing E. coli in ground beef. A dose of 1 kilogram achieved a 5-log reduction. However, residual contamination was detected in low inoculum samples after enrichment. So a dose of 2.5 kilogram was identified as optimal, ensuring effective control of the Shiga toxin producing E. coli, while maintaining consumer acceptance, with no significant sensory difference compared to non-irradiated samples. Now let's talk about food irradiation regulation in Argentina. And in our country, the food code defines 8 classes of food, each with a specific objective and maximum dose limits. The slide shows classes 1 to 4 included bulbs and tubers, fresh fruits and vegetables, cereals, legumes and flours, and spices and dried products. The purpose of irradiation include insect disinfection, phytosanitary treatment, and control of spoilage and pathogenic microorganisms. In this slide, we see classes 5 to 8, which include mushrooms, fish and seafood, meat and poultry. This is now our interest in this meeting, and dried food of animal origin. The objective of irradiation in this group are primarily focused on controlling both spoilage and pathogenic microorganisms, as well as parasite control. One of Argentina's most significant achievements was the inclusion of class 6 and class 7, allowing the irradiation of fishery products and all types of fresh and frozen meat, including beef, pork, poultry, and others. This marks a major step forward, aligning the regulation with food safety goals and international practice for high-risk products. The national agency, the SENASA, is the national agency responsible for agri-food health and quality, and the SENASA adopted the ISBN 28 standard in 2023. This aligns Argentina with global guidelines for phytosanitary treatment using ionizing energy. However, while we do have regulation in the Argentina Food Code that allows the ionizing of meat and fishery products, the Sanitary Authority, SENASA, has not yet regulated the specific process. So the treatment cannot yet be implemented in practice. The irradiation of meat and fishery products. Most countries with regulation for irradiation food require labeling of ionized food. Labeling formats and rules vary, which affect harmonization efforts. According to Codex, the product should clearly state food treated with ionizing energy or contains components treated with ionizing energy. And this must be visible on the label or packaging with the Radura symbol. This is the green symbol. This is the Radura, the international symbol of food irradiation. Now let's look at the context in China, which is a world leader in this field. They have a massive infrastructure and a well-established market for irradiated products. As you can see on the maps, there are 120 gamma facilities and 175 electron beam facilities. This large-scale industrial use, the main products that China irradiates are spices, dehydrated vegetables, processed food, cooked meat product, like ready-to-eat product, this kind of food. About the irradiation regulation in China, currently the framework is based on their food safety law and positive list system. This means that is strict control. There is a strict control over approved food categories, process parameters, and labeling requirements. But there is an ongoing revision because the current rules don't always match market demand. So China is moving from a product-based regulation to a more flexible process-based approach. As noted here, combining their leading infrastructure with these new revisions will enable a significant market expansion. To conclude, to make this work, we need stronger regulations and better infrastructure in Argentina. Food irradiation is a proven tool to improve food safety and access high-value markets. In meat exports specifically, it allows us to shift from frozen to chilled products with a much longer shelf life. And this is a great opportunity to strengthen Argentina's position in key markets like China. Well, thank you for your attention, and these are my contact information. If you need more details or information about irradiation processing in Argentina. Thank you very much.
Okay, thank you, Dr. María Constanza Cova. And the next presentation will be the crown jewel 5-hydroxymethylfurfuran by Dr. Wang Xiaonuan.
Thank you for giving us the opportunity to introduction our company. Our company located in Zhejiang Province, Ningbo City. Company name Zhejiang Sugar Energy Technology. We use the different kind of sugar to produce 5-HMF. We call 5-HMF the crown jewel. I will use the three contexts to explain the detail of our company and the application of the 5-HMF and the preparation of the purpose. The company we are established in 2017. Before that, a lot of persons already know the 5-HMF in different of the natural plants. In recent years, an activity ingredient we called hydraulic method fulfillment. This is the detailed name for the 5-HMF. That has been discovered in variety of traditional Chinese medicines, especially in their fruit and in the roots of the plants. This kind of the product concern a lot of the 5-HMF. This is simultaneously generated through the hydration and the hydrolysis of the glycoside linked in the sugar compounds of these herbals during the processing. 5-HMF consists of one hydrolysis method group, one furanine, and one aldehyde group. We say a century-long patient in the international chemical industry. The scientist method that first reported in 1895, yet not 100-ton scale production has been achieved for more than a century. Ningbo Institute of Material Technology and Engineering, Chinese Academy of Science, is one of the investors for our company, and Jin Haitao also the CEO founder in 5-HMF in sugar energy. Two of the biggest scientists say 5-HMF has been the leader in the mass production of the worldwide. We say awaken the sleeping treasure from the agricultural wastes to a key to carbon neutrality. Hundreds of millions of tons straws are abandoned in the field every year. We use the magic scientific technology to use such kind of the material produce a pure glucose. Biomass-based platform compounds 5-HMF. Hydraulic method fulfuran is the molecule crown of the biomass world. It is a harbor connecting biomass and high-performance materials. An industrial pioneer from the Chinese Academy of Science, Sugar Energy founder in 1917 at the Ningbo Institute of Material Technology and Engineering, Chinese Academy of Science. During many years working hard, we is one of the national high technology enterprise. The world first kiloton scale HMF production line with a market share of over 98%. More than 24 national invitation patients, over 40 total patients to invest with us and play with the 5-HMF together. We can see from the blueprint, we towards 10,000 tons industrial plants in this area. Right now, the world's first kiloton scale production line is operational. In the June of 2026, the commission for us is finished 10,000 tons of 5-HMF at the beginning producer. In the end of 2026, start of the second procedures to construction again. In end of 2028, the 10,000 capacity tons of FDC plant will be finished in there. A world-leading technology mode. We use the fructose according to the green solvent recycle technology. Use the middle reaction systems. Produce 5-HMF. Hold the procedures at normal temperature and normal pressure. The recycling solvent. Fructose consumptions dropped to 1.6 tons HMF. That means 90% of the thermoelectric volume. Low energy consumptions, low pollution, high purity. We think about this is the 3 commercial missions of the 5-HMF. We say the first is the feed additive. Second, sports health. Third, green packing. For the feed additive, we say we can saving more than 5% of gain in feed animal business. And the functions of drinking boosts blood oxidations, we also can use 5-HMF together to help persons healthy. The third starting point for the transitions by our basic plastics with the unlimited applications field. According to research, the 5-HMF in feed and food are huge wide applications. 5-HMF exists widely in nature. We can see from the food, even from the fruits, have a lot of the 5-HMF concern in the fruits and in the root. And we say it also can found in traditional Chinese medicine. A lot of the medicine, they concern 5-HMF. The key point for us is the application of the animal nutrition. China Agricultural University and the Feed Industry Center of Minister of Agriculture, Professor Li Defan, and the scientist layer industry system professor Qiu Gangma help us together during the 3 years to thinking about the feed animals additive use the 5-HMF. Right now, we can say this was the state key laboratory of animal nutrients. China Agricultural University in Feed Industry Center, we say research focus nutritional requirements of no-organized animals, bonding gradients, and feed safety and healthy living stock farmings. This kind of the feed additive can help the animal saving the feed actions and lay more egg. Right now, we application in egg in chickens. The additional of 5-HMF, we can say 10 grams of the 5-HMF laying hens can saving 90 grams per each kg of feed food. So we can say 5% contents of 5-HMF can reduce 200 tons of the feed grains. According to the blueprint, we can see how does the 5-HMF working and how does that make a good efficiency. We use the 4 points to explain the methods of action of 5-HMF as a feed additive. We say inhibit the green of the established strong reduction capacity, oxidation and blood supplement, rapid energy supplier. And we also can use another 3 points to say novel and unique subject, a new feed additive, co-developed by 2 top institutes, new material development by the Chinese Academy of Scientists, new technology applications by China Agricultural University. Second, clean and direct goal, increase income and efficiency, reduce the feed-egg gradient by more than 5%. Third, simple and easy to use. Addition without formulation adjustment. Use the method. Just 2% of 5-HMF contain added to 500 gram per ton completely compound feed, and drop to gain saving the animal covering. From this Excel file, we can see the lay rate, the feed intake, average egg weight are almost at the same. So this one we say we use the layout rate, the laying rate of the control group, decreased by 4 percentage points from 87.8% to 83.8%, while the testing group show an opposition trend, increased slightly from 86.3% to 86.4%. The laying rate of the test group was 4.1% higher than that of control group. The second, feed intake. The average daily feed intake of layers in the control group increased from the 119.2 grams to 122 grams, while that in the test group, this increased from 120 grams to 118.8 grams, a reduction of 2.2 grams compared with the control group. 3. Average egg weight. Average egg weight of both the control group and the test group decreased slightly from 68.2 grams to 64.8 grams, and 65 grams to 68.6 grams. Show the same trend, indicating that the addition of 5-HMF to the diet has no negative efficiency on egg weight. Right now, with development of foundation food established of a joint innovation center in cooperation with Jiangnan University, they will help us doing application in food that an Australian company who use the 5-HMF application in energy drink. During the COVID-19, this kind of the energy drink was very popular because they can help us to increase the oxidation transportation capacity of the blood by proving the blending of oxidation to hemoglobin. HMF can exactly help us to defend the breath problem. So for this way, this was popular during the COVID-19. During more than 10 years experience in the European market, right now they will come to China soon. And for us, we will much more focus to research and development of high-efficiency green bacteria basic on 5-HMF and its method study. And we also development of 5-HMF basic health product and the variation of their function activity. The third, expert dimension on the feasibility of decline 5-HMF as a new food raw material and the safety toxicological valuations. The fourth, launch of the first functions beverage basic on 5-HMF in 2026. About a compilation proposal, we hope overseas business of feed additive, overseas business of function foods, equipment corporation will come to invest in sugar energy technology and create a better future together. Thank you very much. If you have any questions, please contact with me.
Thank you very much, Dr. Wang Xiaonuan, for your presentation. And the next one will be Meat Quality Program of the Argentine Angus Association.
My name is Ignacio Harris. I am a meat technician, a judge of steers and block testers, and a certifier under the Chilean grading law. I am also the meat sector manager for the Argentine Angus Association, a food quality certifier registered with SENASA under Resolution 280 of 2001, which brings together food quality certifiers authorized to provide certification services. We are also registered with the USDA Food Safety and Inspection Service, which allows us to export our label to the United States. In this first slide, what I want to show is the importance of bringing together the primary industry with the refrigeration industry and the consumer, which is what the association is trying to do with these food quality certifications. What is certification? It is evaluating the conformity of a product, process, or service based on a protocol, requirement, or resolution through inspections or audits, culminating in the issuance of a certificate that assures compliance with the corresponding protocol or standard. What benefits does certification bring? First, it facilitates access to better business opportunities. That alone gives us an advantage. It allows us to respond to the requirements of the target market. That is, the market that demands certain guidelines, in this case, as we mentioned, written ones. And it demonstrates compliance with the standards and regulations to which we are being certified. This will give us the confidence of our clients and differentiate us through quality. The Argentine Angus Association has several departments within its structure. These include the registration department, the exhibition department, the auction department, the genomics department, and finally, the meat department. All of these departments focus on continuous improvement, which will be reflected in the final product, high-quality beef. This last area is made up of the CEO, who manages, let's say, all the areas mentioned. There's the management side, which includes me, where I'm the manager and technical director of meat. There's a technical secretariat for meat, and there's also a section within it dedicated to quality meats. And finally, there are the certifiers located in each factory, who certify our quality by carrying out the controls that we'll see shortly. Phenotypic specifications for the first inspection at the slaughterhouse pens. The specifications are black or red Angus, polled, with British crosses through Hereford or Shorthorn, and up to 1/4 Indica crosses are permitted, but primarily British, without significant Indica influence, minimal hump, no brindle markings, not excessively droopy or pendulous ears, and a prominent prepuce. Here are some examples of accepted breeds. As you can see, red Angus, black Angus, hornless, and British crosses are acceptable. White markings on the face or a white face are permitted. White markings are allowed on the chest and belly, but not extending up the sides. White paws are not permitted. Here are examples of rejections in Hereford, animals with a lot of white, excessive overing and brindle from crosses with indigos. As we mentioned, the control process begins in the holding pens, where we observe the cattle destined for slaughter. These cattle must be inspected by our certifier to verify their breed phenotype. These cattle must be registered upon arrival at the slaughterhouse, where they are identified with a AA so that it is known throughout the process that this particular group is destined for Angus certification. The certifier inspects the holding pens and, if deemed suitable for certification, approves the addition of the AA to the slaughter list. Here we observe troops suitable for certification. And here we see cattle that will be rejected, that won't be suitable. For example, when they send cattle for the Angus trait, they send cattle with the Angus specification so they won't be rejected. Okay, here we have the cattle in the pens before entering the slaughterhouse, already on the slaughter list, identified as Angus for certification. And after that inspection in the pens, our staff, trained by the association, performs individual animal checks before removing the hides from the back during slaughter. They check if there are any animals in that group that might be rejected, such as Herefords or any animals that don't meet the specifications mentioned. In a group of 30, it's permitted to have some animals that aren't suitable for certification. These are identified before hide removal with a cross to later identify the hock and confirm that it's a rejected animal. Also, in the case of horns, it's checked to ensure they aren't fixed to the skull. If the horn moves, it means it's not fixed and the animal is accepted. If it's fixed, that animal is rejected. In the slaughtering process, before removing the animal's head from the carcass, a dental check is performed, a dental chronometry test, where the association accepts animals with up to 4 teeth. That is, they cannot exceed approximately 30 months of age. After evisceration and division of the carcass into 2 halves, these pass through the official Argentine classification and grading booth, where the grader classifies the carcass by sex and grades it based on muscle to bone and muscle to fat ratios. In the case of sex grading, with a maximum of 4 teeth, the female animal is a heifer and the male animal is a steer. And if they have more than 4 teeth, they are classified as cows or steers. In the case of Angus, since it accepts up to 4 teeth, the sexes we accept are steer and heifer. And regarding the muscle-to-bone ratio of the 5 grades in the grading system, we only accept A and B, the first 2 grades, with the best conformation, rejecting C, D, and E. The grader also analyzes the degree of fat cover on the beef. Of the 5 grades in the Argentine grading system, fat levels 1, 2, and 3 are accepted for the Angus tax, while 0 fat, completely lean, and 4 fat, excessive, are rejected. Once the work is finished, the cattle go to the aging chamber, and the next day the quartering of the carcasses takes place, where the association checks the marbling of each one, which must be equal to or greater than the slice grade of the USDA classification. When the quarters are going to be butchered, the entry is always verified, just as in the quartering process discussed earlier, with only the Angus qualified cattle entering first. Any rejected cuts enter at the end of the group to prevent mixing. At this stage, in addition to the entry check, the carcasses are inspected for dark cuts, pH levels, if present, bruising, petechiae, and the primary packaging, vacuum sealing and labeling are also checked. After butchering, and once all the primary cuts are vacuum packed and labeled, they are placed in boxes, which are then sealed and stored in cold storage until they are ready for export to their destinations. This is the final step in the certification process for the Argentine Angus beef attribute. As I mentioned, the association aims to connect primary producers with the industry and consumers through the veracity of a certification, a certificate we issue that validates all the controls we have just discussed. In this graph, I want to show the evolution we've had over the last 9 years, where we started exporting less than 1,000 tons in 2017 and steadily increased. Notice how it held steady during the pandemic years. Then, from 2022 onwards, a steady rise began, reaching almost 9,000 tons in 2024 and slightly less in 2025. It's truly an exponential growth, along with the growth in export volume of certified Angus beef that I mentioned earlier. The association supports meatpacking plants attending international trade shows, generally within the stand of the Beef Promotion Institute, where all the exporters gather. We, as the association, also have our own stand, providing support to the meatpacking plants there that certify our product. We also explain our certification to importers and offer them samples of our cuts of beef. As you can see in the graph, this has led to year-on-year growth in the export volume of premium and certified beef, in this case, to China, which last year was the largest exporter of certified Angus beef, followed by the United States and the Netherlands, which round out the top 3. It has been a worthwhile effort, and I believe it has been positive for everyone. Here, we observe the meatpacking plants that export and certify our quality attribute, with Frimsa, Rio Platense, and Garina being among the top 3. Well, hoping I've been as clear as possible and that you've understood this whole process well, I want to say goodbye and, as it says there, especially thank Dr. Noemi Saritsky, who thought I could give this talk on the quality attribute of Argentine Angus beef, as defined by the Argentine Angus Association. Thank you very much. I'll leave you with a final video.
Okay, we will follow with the next presentation. The title is Microbial Pollution and Control from the Perspective of Climate Change, Strategies for Biological Loss Reduction and Value Enhancement of Grain. It will be presented by the Associate Professor Sheng Lina. Please.
Hi everyone, my name is Lina Sheng. I'm Associate Professor from School of Food Science and Technology, Jiangnan University, and I belong to the research group of Professor Xiulan Sun, who is also the Dean of our department. Today, I'm going to present some research from our research group entitled Microbial Pollution and Control from the Perspective of Climate Change, Strategies for Biological Loss Reduction and Value Enhancement of Grain. So first of all, some background. Food security is vital to a nation's lifeline, and food loss is a significant pain point. So mycotoxin contamination poses a long-term threat to food security and contributes significantly to food loss. Globally, 25% of grains are contaminated with mycotoxins each year, with 2% rendered unfit for consumption according to FAO. While in China, 31 million tons of grains are contaminated in the supply chain annually, accounting for 6.2% of the yearly output, according to Chinese Academy of Engineering. On your left-hand side is a mycotoxin risk map for grains in China, and on your right-hand side, as everybody knows, aflatoxin is the most toxic mycotoxin, and the detection rate of aflatoxin in peanuts from southern China and reaches 17.8%. And fusarenum toxin is the most widely spread in terms of hazard. And the contamination rate of fusarenum toxins in wheat from provinces such as Anhui and Jiangsu, which are either our province or a province next to us, and sometimes it can reach 50%. So it's quite high. To make it worse, climate change exaggerates food safety risks and lead to significant waste. So the edible byproducts from grain and oil processing in our country account to over 170 million tons per year, which is a valuable food resource for our country. While extreme climate conditions have heightened the risk of toxins, restricted the utilization of byproducts, and led to an increase of approximately 15% in resource loss. So to sum it up, so extreme climate conditions increase the risk of toxins, and also the utilization rate of byproducts is in a quite low value manner. And new health threats also arise from multi-toxin co-exposure. Well, multi-toxin or multi-macrotoxin contamination is an important and persistent hazard in the food chain, with increasing level of co-contamination and the synergistic effect between toxins. The contamination by mixed toxin is widespread, and the long-term low-level exposure of the population to macrotoxins in their diet remains unclear. So what people are truly concerned about is the long-term exposure to these toxins in small doses through diet could have adverse effects on human health. So to address these concerns, we have made efforts through different aspects. The first one is we switched from passive detection to prediction and early warning. So first of all, we established a global macrotoxin prediction model from the perspective of climate change. And this prediction model is specifically for aflatoxin first because AFB1 is the most toxic macrotoxin, and it's developed to characterize the contamination patterns in major maize growing regions. And so on the left-hand side is a distribution of aflatoxins in maize. It shows it exhibits distinct non-linear characteristics and regional differences. And also, we applied interpretable machine learning. It reveals that temperature is a key climbing factor affecting the fungal toxin contamination level during maize growth. And when the temperature rises by 1 to 2 degrees Celsius, a bipolar migration phenomenon of aflatoxins occurs, and there is an overlapping risk in the global golden corn belt. And under the prediction scenario of global climate models, the level of aflatoxin contamination in corn will increase by 60.83 to 81.28%. And we also independently developed the first dynamic early warning database for hidden toxins. Hidden toxins or masked toxins, they are referred to toxins, macrotoxins that they are combined with food components such as amino acids or sugar. And the reason why we are worried about it is because we cannot detect the original ones using the regular method, but indeed they are there. And also when we consume it in the human body, this hidden toxin has its own toxicity. In addition, when they are hydrolyzed and they're released in their original format, they can further activate toxicity of the original macrotoxin. Therefore, we developed a predictive model for masked or hidden toxins, and it's a publicly accessible database called Macrotoxin DB. And by integrating high-resolution mass spectrometry, dedicated research pathways was established for the screening and identification of masked toxins in grains. And in this database, we have over 3,000 hidden or masked toxin, and we have inputted 5,000 papers. And we include 70,000 chemical reactions and 8,000 biochemical reactions. And we also elucidated the mechanism of mycotoxin production regulated by the coupled feedback of environmental factors. So based on over a decade of mycotoxin contamination data, which exceeding 3 million entries from major grain producing regions, we analyzed the spatial temporal dynamics and variation patterns. And the key molecular suite for synthesis, the AFLS/AFLR transcriptional factor regulator, was determined by elucidating the feedback mechanism of pre-critical temperature and water activity on mycotoxin synthesis. The reason why we are working on it is because as global change, so temperature, water activity, and light exposure, they played an important role. It's reflected by climate change. So we just want to know how these factors can influence mycotoxin production. We also established a toxin detection and early warning platform, and this is a data-driven approach. It enabled early warning of toxigenic fungal contamination in the field. And multi-modal image recognition was employed to predict fungal contamination in maize, and with a prediction accuracy ranging from 87.73% to 91.91%. The second section, or the second effort we made, is we not only want to know the toxic effects of multi-toxin co-exposure, as well as some emergent or hidden toxins, but also we have developed some grain prevention and control measures. So first of all, the new risk of direct exposure to fungi and mycotoxins in human. As we have mentioned earlier, multi-toxin co-exposure is a common thing. So we developed a one-step method for detection of exposure to 67 toxins in the population cohort, and with 184 people. And as we screened for emergent we screened of 24 emergent toxins. For emergent toxins, they mean like, for example, aflatoxins. They are toxins. It's already well known. It's well regulated. Well, there are also some other macrotoxins. They are relatively new, and there's not a quite established regulation for those, and they are called emergent toxins. And as you can see here, 24 types of emergent toxins were detected, were screened, and simultaneous exposure to more than 7 types of toxins is found in 59.6% of infertility cases. In addition to the traditional toxicity like cancer, immune system dysfunction, liver damage, kidney damage, and reproductive toxicity, and we're also wondering whether there are some non-traditional or novel toxicity of macrotoxins. So the work we have done first, we found that the neurotoxicity of emergent toxin, cyclopizonic acid or CPA, it can cross the body. It accumulates in the hippocampus, and it can cause imbalance of neurotransmitters and dysfunction of key metabolic pathways, and also anxiety-like behaviors and spatial learning and memory and cognitive impairments. Another thing is about virilino, and for this traditional toxin, we found that co-exposure, a chronic exposure to it, can induce liver lipid accumulation and impairment of intestinal barrier function, and also remodeling of liver lipids and intestinal microbiota composition through the gut-liver axis. And chronic exposure to citrulline and alcohol, for example, the citrulline, it can, and its metabolites in the liver, kidney, and hippocampus will increase, and the increase in CIT metabolites is positively correlated with tryptophan metabolism and others, and negatively correlated with purine metabolism. And it can also cause damage to our brain through gut, liver, kidney, brain axis. In addition to the toxicity of mycotoxins, it's worth mentioning that during grain harvest seasons, and workers, they are likely exposed to fungal spores at a relatively high concentration. Well, we found, therefore, we have conducted research on the lung toxicity of fungal spores through inhalation, and fungal spore exposure resulted in weight loss, lung bleeding, increased inflammatory factors, and decreased diversity of lung flora in mice. And it's mainly, the damage are mainly through lung triglyceride and galactose metabolic disorders, and also the fungal spores simulate alveolar macrophages, activate NF-kappa-B pathway and apoptosis signal. But gut microbiota can regulate the susceptibility of fungal pneumonia caused by Fusarium graminearum spores through the gut-lung axis. So in order to deal with this pathogenic fungi, we developed a machine learning framework which screened for broad spectrum antifungal peptides. So we constructed a classification, ranking, and regression 3-level machine learning framework. It integrates AlphaFold2 and ProteinBird to obtain high-dimensional features and screen high effective antifungal peptides through 2.5 billion 14 peptides database. And one peptide we screened is called AFPVR. It disrupts the homeostasis of Aspergillus flavus cell wall and targets phospholipids on the cell membrane. And we applied this peptide we screened into a combined invasive pulmonary aspergillosis. And we found that it has an inhibitory rate against Aspergillus flavus in the lung as high as 85.08%, which is comparable to a commonly used antifungal drug. And we also applied our technologies and devices in the industry. So we developed a new integrated device for highly sensitive fluorescence detection and take the lead in formulating the first in international ISO standard for toxin detection led by China. And we also developed a high coverage mass spectrometry detection method for toxin metabolites. And these devices or kits has been applied in Belt and Road countries. And we also developed intelligent equipment for grading and sorting microtoxins in grains, and the flow grain monitoring and sampling device or grain laser sorting device achieve early screening of microtoxins. And we also mined and constructed a food grade biocontrol strain library with high inhibitory activity. So we isolated 16,000 new industry grade biocontrol strains and identified 351 active strains, and 65 strains of which have ability to degrade microtoxins. And also one strain, we formulated a patent and received the Chinese Patent Excellent Award. We also developed bacterial cocktails to improve the quality and efficiency of byproducts, and invented the integrated green technologies and devices for microtoxin removal. For example, a bioreduction and removal technology assisted by ultrasonic multi-layer countercurrent was established, and it achieved a removal efficiency of 25.7%. That's all for today. Thank you very much for listening.
Well, thank you very much to Professor Sheng Lina. And our next talk will be given by Dr. Sofia Schulze in a similar subject, mycotoxins in Argentina, current status and control strategies. Please, the next talk.
Good morning in Argentina and good afternoon in China. It is a great pleasure to be here today. I would like to sincerely thank Professor Dr. Zariski and the Argentine Academy of Engineering for the kind invitation to participate in this webinar. I am glad to share this webinar with colleagues from China and Argentina. I am Sofia Noemi Schulze. I am Emeritus Professor at the National University of Rio Cuarto and retired senior researcher at CONICET, Argentina's National Council for Scientific and technical research. I am working at Research Institute on Mycology and Mycotoxicology. The presentation will deal with a background, mycotoxin in Argentina, legislation, mycotoxin-related studies done in our institute, for crop production, agro-industry, and cattle breeding. The university was established in 1971. The Institute on Mycology and Mycotoxicology, MICO, belongs to the National Scientific and Technical Research Council, CONICET, and the National University of Rio Cuarto. The aims of the Institute are to promote the advancement of scientific and technological knowledge in the field of mycology and mycotoxicology, to study the biodiversity, ecophysiology, and genetic diversity of pathogen and or toxigenic fungi, mainly species of the genera Fusarium, Aspergillus, and Alternaria, in the main crops of relevance for the Argentinian economy. To evaluate and to implement strategies to reduce the incidence of pathogen and or toxigenic fungi to prevent the entry of mycotoxin into the food and feed chains. To develop bioinput using native microorganisms to be used in the frame of an integrated pest management. What are mycotoxins? Mycotoxins are secondary metabolites produced mainly by species of the genera Aspergillus, Fusarium, Penicillium, and Alternaria. They have different chemical structure. They are contaminants of different crop, vegetable, and subproducts. They cause health effects such as liver cancer, nephrotoxicity, neurotoxicity, immunosuppression, stunted growth. One of the major concerns with mycotoxin is their ability to move through the food chain, starting from contaminated crops and reaching in the field and reaching the food of the consumer and the food of the animals, thereby amplifying their impact on food safety and public health. Also, mycotoxins represent a significant global challenge causing economic losses due to their impact on human and animal health, as well as on agriculture productivity and market access. Climate change can influence the occurrence of mycotoxin and distribution of mycotoxin and the biodiversity of toxigenic fungi. This is important since this scenario poses significant challenges for food safety, agriculture sustainability, and global trade, making it essential to develop strategies to mitigate the problem. These are the mycotoxins that we consider relevant in Argentina: aflatoxin, fumonisin, trichoticin, mainly deoxynivalenol and nivalenol, cearalenol, ochratoxin A, and some emerging mycotoxins such as Alternaria mycotoxins. In Argentina, we have public and private accredited laboratories. They are using detection methods for this toxin using HPLC with UV and fluorescent detectors, and HPLC MS. And in Argentina, we are working to develop strategies to mitigate the impact of mycotoxin. Which are the mycotoxin limits? The limits are established for the main toxin that can be found of natural occurrence in different crops, like aflatoxin, ochratoxin A, fumonisin, deoxynivalenol, cearalenol, and patulin, and depending on the product, there are different limits of the different toxins. For example, 10 micrograms by kilogram for total aflatoxin in dry fruit, 5 micrograms by kilogram for coffee, 2,000 micrograms by kilogram for maize flour and from fumonisin, and 1,000 micrograms by kilogram for maize and wheat products for deoxynivalenol. Cearalenol, also there are different limits depending on the products, and patulin, the limit is 50 micrograms by kilogram for apple juices and subproducts derived from apples. The Mercosur, the South Common Market, that integrated by several countries like Argentina, Brazil, Uruguay, and Paraguay, have established maximum level for aflatoxin in different products like milk, peanuts, and maize. Mainly aflatoxin N1, that is, this toxin has high toxicity and is a hydroxylide derivative from aflatoxin B1. Aflatoxin N1 is secreted in dairy cattle by milk. In dairy cattle that are normally feeding with contaminated products with aflatoxin B1. In maize, also, total aflatoxin is 20 micrograms by kilogram. In peanuts and peanut butter, also total aflatoxin 20 micrograms by kilogram. The last regulation in Argentina was 2025, established limit for dry fruit, except peanuts, almonds, nuts, and pistachio, for total aflatoxin, also for apple juice and solid products based on apple, for patulin, and maize flour and wheat flour for cearalenol, and food intended for children and lactants, also low level of cearalenol were established. The studies that we have done in Argentina, mainly on toxigenic fungi and mycotoxin, the natural occurrence. We have been working on wheat, maize, soybean, and grapes, and different species like Fusarium graminearum species from the Fusarium graminearum clade. The main species found in Argentina is Fusarium graminearum sensu stricto, and the toxin of concern is the oxynivalenol. Depending on the year, the concentration of the oxynivalenol that we can find is different. When there is epiphytia or not of fungal infection on wheat, some years the contamination could be high and other years low. In maize, the main species are Fusarium fujikuroi species complex with Fusarium proliferatum, Fusarium verticilloides, Fusarium temperatum, and Fusarium subglutinum, the main species that we isolate, and Fusarium graminearum also from maize. The toxin of concern is fumonisin, that the concentration detected also is depending on the year. In soybean, Aspergillus section flavi, Aspergillus flavus, and Aspergillus parasiticus, with the level of aflatoxin not so high. In grapes, Aspergillus section niger and Aspergillus carbonarium, and ochratoxin contamination also was not so high. In grapes, raisin, and wine. One of the last studies was done on fumonisin in food for children, a food based on wheat flour, rye flour, and maize flour. Although we found 84% of samples contaminated, you can see the range is so wide, and most of the samples were contaminated with less than 200 micrograms by kilogram. Another toxin that we have studied are alternaria mycotoxin. During 2022, the European Union published a recommendation for the levels of toxin produced by Alternaria genera, mainly for toxin like alternariol, alternarium monomethylated alternasonic acid. We have evaluated some wheat samples, also some samples based on apples, and some samples based on tomato, and some subproducts derived from tomatoes, and wine samples. We found mainly atenareol, atenomethylate, and tenosonic acid. The concentration was variable, and also in tomatoes we found another toxin like tentoxin, artetoxin, and atenueno, but the levels were not so high, except sometimes for tenosonic acid. Another aspect that we consider interesting was to evaluate the biodiversity of fusarium endophytes from natural grasses. And why we start with this topic? Since in years before 2015, we have a demand from beef cattle farm because they were blamed to use anabolic like ceranol in the beef cattle. We were studying to evaluate if ceranol, that is a derivative of cerealenol, is a derivative of cerealenona, could be present in natural grasses in the beef cattle farm where positive urina samples for cerealenol were previamente found. We studied both the fusarium species and cerealenol in these natural grasses that were used to feed beef cattle. In different years, we found that cerealenol, alpha cerealenol, and beta cerealenol could be found in the natural grasses. And so that we demonstrate that the presence of cerealenol in urine of beef cattle may not be a consequence of illegal use of the banned substance, but the product of the natural occurrence of cerealenol and alpha cerealenol in natural grasses intended for cattle feeding. Also, we were able to detect co-occurrence of cerealenol and several metabolites of cerealenol for the first time in natural grasses. The study was done in 2 years in order to show that these findings were not sporadic cases. We studied the biodiversity of fusarium endophytes for these natural grasses, and we found species from the Fusarium sambucinum species complex, Fusarium fujikuroi species complex, and Fusarium incarnatum equiseti species complex, and we were able to identify new species for Argentina as Fusarium chaquensis and Fusarium balzacianum from different Fusarium species complex. In relation to prevention strategies approaches, we were studying 4 pathosystems: Fusarium in wheat, disease and deoxynivalenol; Aspergillus in maize, disease and aflatoxin; Aspergillus in peanut, foliar disease and aflatoxin; Fusarium alternaria in tomato, disease control. We also studied the population of Fusarium gramineanum, sensu stricto, genotype, chemotype, and genetic diversity. We found that the main genotype and chemotype of Fusarium gramineanum sensu stricto in Argentina is 15 acetyl producer, and some years we can find more than 3 acetyl producer. In relation to population structure, Fusarium gramineanum sensu stricto is only a big population that have high level of migration between one place and another, and this population is has high genotypic diversity. In relation to biological control to mitigate Fusarium head blight in wheat, we have done a bioprospection of different areas, looking for native microorganisms to be used as biological control agent to reduce the impact of Fusarium head blight and deoxynivalenol production. I will show an example for Bacillus belizensis that we were able to show that this bacteria reduce both Fusarium head blight disease and also deoxynivalenol production. Also, using different wheat varieties, we showed that the biocontrol could reduce both DON production and Fusarium head blight in disease severity. 5 years studies, we showed that both in bread wheat and durum wheat, disease reduction and also deoxynivalenol reduction using the biocontrol agent. We were able to register the product in Argentina. The same strategy was used in barley to control deoxynivalenol production during the malting process, and we get successful result in deoxynivalenol reduction during the malting process using biocontrol strategy. Biological control, we are also evaluating using filamental fungi, Aspergillus flavus not toxigenic, that based on the competitive exclusion, eliminate toxigenic strain of Aspergillus flavus and reduce the impact of aflatoxin. We studied this in maize and peanuts, and we were able to show that using this bioinput at the field stage on the soil, we were able to at harvest have less production of aflatoxin both in peanuts and maize, and also the application at the field stage have residual effect during storage at least during 6 months. This product is under patent request. The strategies that we are using is using fungal lacases and zinc oxide-based nanoparticles for the reduction of aflatoxin and fumonisin in maize and byproducts. We use lacases enzyme isolated from filamental fungi from the phylum Basidiomycota, and also zinc oxide-based nanoparticles, and we show reduction of aflatoxin and fumonisin. Challenges are to continue the evaluation of the occurrence of mycotoxin in different crops and byproducts of the national importance for both domestic consumption and export markets, to going on with the study of biodiversity of toxigenic fungi under climate change scenarios in order to determine risk map for mycotoxin and the occurrence of emerging mycotoxin, to evaluate strategies to mitigate mycotoxin in the frame of integrated control management, including biocontrol and other strategies. We received national and international funding, national support from the Secretary of Science and Technology from our university, from the National Research Council from Argentina, CONICET, and the National Agency for Scientific and Technological Research. And also we received funding from the European Union in several projects, MycoRed, MycoKey, and BasiPro. I will be glad to answer your question.
Okay. Thank you, Dr. Schulze, for your presentation. And we are going with the last one, application of multiplex detection technology in the field of food authenticity identification by Professor Sang Xiu Kim.
Hello, everyone. I'm Zhang Xiuqin from Central Testing International Group Co. Limited. The content I'm going to share is the application of multi-detection technology in the field of food adulteration. CTI is a comprehensive inspection, testing, and certification organization and the first listed company in China's TIC industry. It was founded in 2003 and listed on the growth enterprise market in Hong Kong in 2009. After 20 years of development, it now has more than 160 labs and over 14,000 employees, more than 100,000 customers, and issued over 4 million reports each year. Our service covers all over China with 21 large labs and more than 500 quick testing labs in the food sector alone. We have offices in 20 countries around the world. And with the advancement of our internationalization strategy, we have already established our own labs in Singapore, France, and South Africa. We test samples ranging from bacteria to seeds. Just as our group vision describes, CTI is always by your side. In the food sector, we offer one-stop service from farm to table. Today's sharing is a part of our food division's work. Application of multiplex detection technology in the field of food authenticity identification. With the globalization of trade and the cross-border flow of goods, food adulteration is no longer a problem of one country or one region, but a risk to the global supply chain. Adulterated food is indistinguishable from the genuine product in appearance and taste, and it is difficult to identify with the naked eye or by simple means. With the advancement of technology, the means of adulteration are constantly being updated, specifically avoiding a single detection method. Using data analysis to optimize the counterfeiting process and challenging regulatory limits. Relying on a single indicator or technology can only reveal partial characteristics of the authenticity of food and cannot make a comprehensive judgment, making it easy for counterfeiters to circumvent it specifically. A single detection technique is like the blind man touching the elephant. Each person only feels a part of it, and they cannot know what the real elephant looks like. But by conducting a comprehensive analysis from multiple dimensions, such as composition, structure, and source, to form a complete chain of evidence that can effectively identify complex facts, precise identification can be achieved. Therefore, food authenticity testing must rely on multiple detection technologies, starting from multiple dimensions to form a closed-loop verification system, effectively dealing with complex adulteration methods and ensuring the accuracy and the reliability of the test results. Regarding the construction of the multi-detection technology system, the first dimension is spectral technology, which is the sharp eyes for rapid detection, using the absorption and the scattering characteristics of substance to different wavelength light, to quickly screen out suspicious samples from a vast number of samples. Conventional physical-chemical testing techniques, chromatography techniques, and mass spectrometry techniques can be used for precise analysis of food components and adulterants and for rapid identification of exogenous additives. Isotope technology, an important part of multiplex detection techniques, is indispensable in most food authenticity tests as an important means of food origin and traceability. Molecular biology techniques are indispensable in the technology metric, as each species has its unique genetic ID card, which can be used to effectively identify meat adulteration, genetically modified components, analysis, etc. Case 1. Among all kinds of foods, adulteration of vegetable oil is common and difficult to identify, and there is a saying that adulteration of vegetable oil, even ghosts, would be worried. The common method of adulteration is to mix low-priced oil with high-priced oil, such as blending soybean oil, sunflower oil, etc., into extra virgin olive oil. For the detection of oil adulteration, we use 4 levels. First, we use near-infrared spectroscopy technology and pre-established models to analyze the spectral characteristics of the sample and determine the authenticity of the sample. The second level uses chromatography technology to detect important nutritional indicators of the oil, fatty acids. The third level uses chromatography to detect another important indicator of the oil, sterols. The fourth level detects special substance in the sample. Not every sample requires all 4 levels to be tested. Sometimes, for a sample that is obviously fake, 2 or 3 levels can be used to determine whether it is genuine or not. If it is a deliberate or adulteration, 4 levels will need to be tested. Case 2. Authenticity testing of juice has always been a concern of the World Juice Association. The European Fruit and Vegetable Juice Association has set up authenticity indicators for 27 kinds of juice, providing important technical support for authenticity testing of juice in various countries. There are 3 main ways to adulterate coconut juice. One is to pass off concentrated and reconstituted coconut juice as NFC coconut juice. The second is to add excess water to the coconut juice and then artificially adjust the key indicators. The third is to mix sugar and syrup directly and then adjust other indicators. For the authenticity test of coconut juice, we use multiple detection techniques simultaneously. Traditional physical-chemical detection techniques were used to test indicators such as soluble total solids, amino acid nitrogens, total acid, pH, protein, etc. Mass spectrometer was used to test minerals and flavoring agents. Chromatography is used to detect sugars, organic acids, amino acids, exogenous preservatives, solubilizers, etc. Isotope technology for the detection of carbon hydrogen, and oxygen isotopes. A comprehensive analysis of all data was conducted against our real sample database and the technical guidance documents of the European Fruit and Vegetable Juice Association to evaluate the authenticity of the samples. These two are typical cases of our use of multiplex detection technology to test the authenticity of food. Regarding the outlook for the future, in the TIC industry, third-party testing groups with strong comprehensive capabilities will become the bridge for transmitting trust between all consumers and merchants, and the guarantee of healthy consumptions because of the comprehensiveness of their technology platforms, their global service capabilities, and their method research and development capabilities. With the development of the technology and the demands of global trade, the future TIC industry may increasingly tend towards standardization, intelligence, and high throughput. That is all my communication. Thanks, everybody.
Thank you very much, Professor Sang Siew Kim, for your presentation. And we will begin the discussion session. Is there any questions? I suggest to send the emails of all the speakers in order to perhaps make questions via email. Margarita, you can provide the emails of the participants from China and from Argentina, so they can ask questions and to receive answers via email, if there are no questions now.
Yeah, okay. By the way, our president, Professor Chen Wei, has already sent a detailed email for you that invite you to China to attend the international conference in maybe November 6th to 8th. So maybe you can check the email and about the detailed. Yeah, okay. Thank you.
Thanks. Yeah, the list of the emails will be useful for all the participants in order to establish research contact, perhaps in subjects that are similar. For example, mycotoxins. We have two interesting talks about this subject. I don't know if is there any question?
Yes, Dr. Sariski, excuse me. I would like to.
Please.
Yeah, okay. Thank you for the webinar. I enjoyed the meeting. I would like to ask Dr. Lina Shen, because she talked about mycotoxins. I have been working in connection with China on mycotoxins since I participated in two projects, ANI-CAE, I said before, and there were a lot of Chinese researchers participating from different places. No? Which are the main toxins that you are now focused on? You said that about emerging mycotoxin. Also, we are interested in some emerging mycotoxins like barbericin, for example, because we are studying Fusarium fujikuroi species complex and Fusarium temperatum and subglutinum, and there are some production of this barbericin toxin, no?
Yeah, Currently, I think we are mainly working on aflatoxin, but we also use enzyme to degrade aflatoxin and other traditional macrotoxins. And but in the meantime, we are studying the toxicities of some emerging, like more novel macrotoxins as well.
That is a very important aspect because that is the data that we need about the toxicity, and sometimes about the mixture of mycotoxin, because the mycotoxin came not alone.
Exactly. Yeah, we have done lots of work about the combined toxicity of multiple macrotoxins.
Sorry. Junfei Xie, I would like to ask you to send your publications about artificial intelligence, because it's a very interesting subject and we have not developed this area in Argentina, and we are very interested in to make a connection with you about this subject. So
Of course.
I invite you to send us the list, because I didn't see the list of publication in your presentation. I think it's huge. So please send us the information. It will be very useful for us.
Okay, no problem. After that, I will email you. Yeah, okay.
Okay, thank you very much.
You're welcome.
Okay, I don't know if is there any other question? So
sorry, I have a question for the
yeah.
beef. I saw that you do some maybe for the image, or you do some something else about the beef, but I want to check if you have some gene analysis detection about the beef, because a company in China, they want to build a company maybe for a lot of beef, but they didn't know. They want to check the beef is maybe the good one or not one. So they want to build a lab for detection, maybe for gene detection. So I didn't know in Argentina if you have some the identification for the beef for gene identification. Okay, thank you.
Ignacio Harris is not present in this discussion because he's traveling, but he told me you can send him an email with a question, and he will answer about this question.
Okay, thank you.
You're welcome. So I think it was a very, very interesting webinar. And on behalf of the organizers of this webinar, I would like to sincerely thank our speakers from China and from Argentina for their insightful presentations and for sharing their expertise with us today. All your contributions have added great value to this webinar, and we truly appreciate the time and effort you dedicated for preparing and presenting the result. We also thank everyone who participated in this webinar and hope to have their presence in future events. So we will see I think in 1 month, 1 or 2 months, in the 4th webinar in the frame of this project. Thank you to all. And we finish this webinar.
Okay.
Thank you.
Thank you. Okay, bye-bye.
You.
Bye.
Thank you very
Thank
much.
you.